How to solve a polarity problem. First, we're going to look at the question. How many of these molecules are polar? So we're going to look at these 5 molecules in multiple steps. First, we'll draw the Lewis structure. Then we'll look at the electronegativity and draw the bond dipoles accordingly. Then we'll identify partial charges and identify the net molecular dipole, which will help us understand if it's polar or nonpolar. So molecule 1, we have SO3. So it has 24 valence electrons. So I start with putting bonds here and then filling the outer octets. Once I did that, I had used 22 electrons, so I had 2 left over. So that told me I should put it on the sulfur to give that a full octet too. So there's your Lewis structure, and you can count to make sure you have 24. Then we're going to look at the electronegativities. S has a smaller electronegativity than O. So your S is going to have a partial positive charge. Your O is going to have, all your O's surrounding it are going to have partial negatives. And then that helps you with the bond dipoles. You start with the positive head and go out towards the negative O for all 3. For the molecular net dipole, so your molecular geometry is trigonal planar, since there's 3 domains. There's going to be no net dipole since all of these are going to cancel out. Therefore, this is a nonpolar molecule. Your second molecule is OF2. So here's the Lewis structure. You can make sure 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 valence electrons are used. They all have full octets. Your electronegativity, so your F is going to be more electronegative. So your F's are going to have the partial negatives with the O having the partial positive. Then you can draw your bond dipoles, O with the partial positive going outwards toward the negative F. Your molecular geometry is going to be bent. Because it has 4 domains but 2 lone pairs, that gives it the bent molecular geometry. So you're going to have a net dipole going down like this, and that gives you a polar molecule. Your third molecule is BeCl2, 16 valence electrons. So I fill my outer atoms first with octets. I run out of electrons, so I just remember that Be is one of the exceptions to the octet rule. So it doesn't have to have the full 8 electrons. So that's the correct Lewis structure. The electronegativity, Cl is more electronegative, so it's going to have the partial negative charges with Be having partial positive. Then your bond dipoles, your positive going towards your negative Cl. Your molecular geometry is going to be linear since it has 2 domains. There's going to be no net dipole because these 2 are going to cancel out, so it's going to be nonpolar. Your fourth molecule is CCl4, 32 valence electrons. So the carbon gets your 4 bonds, and then each chlorine has 8 outer electrons with a full octet. Your electronegativity, so chlorine is going to be more electronegative, so it's going to have the partial negatives, all 4 of them with the partial positive carbon in the center. Then you draw your bond dipoles like this. Your molecular geometry, since it has 4 domains, it's going to be tetrahedral. There's going to be no net dipole because they're all going to cancel each other out. So this molecule is also nonpolar. Your final molecule is ozone, O3. So it has 18 valence electrons. This was the original Lewis structure I drew. Since there was a double bond, I could see that it was going to have resonance. However, each resonance is equal when you do the formal charges, so you can use either one. We're not going to draw, for electronegativity, it's all O's with 3.5, so there's no partial charges. And we're not going to draw bond dipoles either. Your molecular geometry is going to be bent because there's 3 domains, but one of them has a lone pair. So that's what makes it bent. There is going to be a bond dipole, and with this lone pair, it's going to be a polar molecule. So what did we find? We found that SO3 is nonpolar, OF2 is polar, BeCl2 is nonpolar, CCl4 is nonpolar, and O3 is polar. So the question was how many are polar? You're going to get 2 polar molecules. And a good way of looking at that is if the molecule has a molecular dipole, it's going to be polar. If it doesn't, it's going to be nonpolar. Some common mistakes is drawing Lewis structures, so not knowing the valence electrons and just being lazy and not writing them correctly. 2 is forgetting the exceptions, so you have to remember the ones that can have less than 8 and ones that can have more than 8 electrons around it. 3rd is forgetting about non-bonding electrons. So when you're thinking about your structures, you have to remember the lone pairs to know your geometries. And the 4th one is not knowing the geometry, so not knowing the names and which ones look like what, because it really helps when you understand what the geometries look like.